cloud computing, and now we'll start discussing about edge computing. The basic crux of edge computing is the processing of data near where data is generated, means its source. Why? Why we are using edge computing sometimes over cloud computing? It reduces latency. Such we play games, and there are some autonomous cars like Tesla which need very low latency to make decisions as quickly as possible. And bandwidth use. Bandwidth is really expensive sometimes, and with communicating with cloud servers, it really is a big issue. So it reduces bandwidth consumption and dependency on distant data centers. So if distant data center is crashed, it will still run. The key characteristics of edge computing is proximity to data sources. As I've said, it processes near where its data is generated, like gateways or local servers. Low latency, as I've mentioned. Bandwidth optimization. An example of bandwidth optimization is like CCTV cameras, which I have made a project also. CCTV cameras capture a lot of data which is stored generally in cloud servers, usually today's world. But this much storage is expensive, so like some motion is detected and we have to send it to, so that can reduce the bandwidth. And offline capability, it runs offline also. As we can say, the edge layer is between the cloud layer and the device layer. The devices communicate with edge servers and the edge layer communicates with cloud layers. Use cases and application: industrial IoT, Internet of Things, predictive maintenance in manufacturing. It can predict when a machine is likely to fail and requires maintenance before it crashes. So it generally helps a lot. In healthcare, as we know, ECG, BP machines, etc. are very useful. Retail, personalized store experiences, analytics like if something is out of stock, if something is high in demand, we can access it and imply it in the store. Real world example, as I mentioned, Tesla Autopilot. It has sensors which are IoT, we can say 5G networks for reduced latency. Here is a project that I have made for CCTV. Oh, sorry. Okay, as you can see, here is a CCTV camera, and it's just my laptop camera. So here I have mentioned a motion, and here started recording and saving clip. Just it will maintain a 30-second buffer and will store that clip here, like 30-second buffer, and it has stored only the motion here. So it really helps in bandwidth optimization, benefit speed, reduce latency, also speed is fast, cost savings. As I have said, cloud servers data management is expensive, and privacy security. As the data is processing near its source, it's unlikely to breach, and reliability works offline also. Challenges: its infrastructure. The elements in cloud edge computing are a bit expensive, as they reduce latency and high in performance, so obviously they are going to be expensive. Its complexity: there are a lot of distributed systems, as we can see in Tesla Autopilot. There are a ton of sensors, so managing all these sensors are a bit complex, and a bit security risk of physical tampering. And here's the difference between edge and cloud computing. Edge computing latency is low, cloud computing latency high. Data location: it is processed locally, and cloud computing servers have centralized data centers which communicate to back and forth with the elements, or we can say devices. Use cases: real-time apps, which real-time decision making is needed. We use edge computing, and big data analysis for cloud computing. Bandwidth is optimized, as I have mentioned, and here is high consumption of bandwidth. Thank you so much.
मेरा प्रोजेक्ट 1 मिनट